So, hello everyone. To continue, going to talk about foldable drones for plant inspection in harsh environments. And I'm going to talk, I'm Perez, I work for Orano.
I am Luc Ayral, I am Operation Manager in Aeraccess.
So, to repeat myself for the people who are not here, the EEC 4.0 innovation is built around 5 main pillars. So augmented operator, connected plant and mines, digital engineering, connected logistics and transport, and proactive waste management. This is the part where we collaborate with startups, and to do that we have a major program called UDD, when we raise 10 million grants from the French government. And it's allow us to work on ambitious projects as the project where we work. So today we are going to talk about augmented operator with Aeraccess, and on a special use case, who is the corrosion measure with NDT in harsh environment. It's a major issue for us because the problem is to measure the corrosion inside zone 4. Zone 4 is an unallowed human zone because high radioactivity zone. And we have a lot of huge problem in this zone because it's all metallic, so no GPS is allowed, complex geometry, and we just have a unique access with a 100 diameters to put some element inside. So moreover, we don't have light inside or really little light inside, so it's really hard to see what is going inside. So to do that, we develop with Aeraccess a drone.
Thank you a lot, Pacom. So Aeraccess is a French leading designer and manufacturer of drones, outdoor drones and also indoor drones. And we have a partnership with Orano since 5 years. So, and we, in the scope of this project and to answer the different needs for the inspection in zone 4 cells, we invented a new drone that is a foldable drone. So here you have the picture of the drone in the folded position and on the right on the unfolded position. And this is done in order that the drone can be introduced in the zone 4 cells through a tube of 10 centimeter diameter. And the drone is equipped with anti-collision sensor all around, 26 anti-collision sensors. And also it has 4 key camera for visual inspection. This is one of the missions. Globally, the missions are threefold in the high radiation zones, visual inspection with the camera, but also, as Pacom said, non-destructive testing, that is for thickness measurement of the metallic equipment inside the zones. And this is done with an ultrasonic probe, which is installed, embarked in the front of the drone. And also the drone can be equipped with a very miniaturized dosimetric sensor in order to make radiation doses measurements inside the cells.
Yeah, the goal of this drone is to have different mission. The first mission is to measure corrosion, but when we have the drone, and this is the main issue of our problem, is how we can put a drone inside a so small tube. So Aeraccess invent this, and when we have the drone, we want to do for different missions. It's for that we develop another thing to put on the drone is the dosimetric sensor. Dosimetric sensor allow us to measure radioactivity and to understand how it's work inside. So moreover, the drone have anti-collision system because we have small vision inside and the drone can fall down, and we need to know where the drone is and help pilots to understand how the environment can work, because it's really harsh, really dark, and we can't take a drone out, so the drone can't fall.
So this is the first video where in our indoor capabilities where you can see the efficiency of the anti-collision sensors all around the drone. So the drone cannot hit here the people, but in the cells, the walls and the metallic equipment inside high resolution zone cells.
This is pretty new on this kind of drone because it's all developed drone. And another stuff of this drone is when the drone.
So here you have a video to show when the drone wants to make measurements on the target. So the target is shown on the right. The measurement arms goes down, and then the drone goes to the target, touch the target in order to make the measurement with the ultrasonic probe. For that, we need a precision of a few centimeters in the navigation capabilities, which is quite tough. And we will see after that we are working also to improve all these navigation capabilities.
And you need to know that that is really unnatural for a drone, because when the drone go close to a wall, they create wind. So it's really unnatural for a drone to touch a surface like that. And moreover, for that, we have the anti-collision system who don't allow the drone to touch a wall. So this is really unnatural for a drone, but we arrived to do that with Aeraccess. So this is really cool.
And as I said, we have a lot of work in progress, and this is done in the scope of the UDD at Orano program that Pacom presented. And in the scope of this program, we are working to improve globally the navigation capabilities of the drone, the positioning precision on the drone, and also the avoidance of obstacles in a very complex environment of the Zone 4 cells. For that, we have a partnership with the company Perez, which is an artificial intelligence expert. And we choose to use on the drone SLAM technologies. This is what we are using, stereoscopic vision with 2 cameras in the front of the drone in order to get images and to reconstruct through a SLAM algorithm, which are embedded in the processor of the drone, cloud of points and cloud of obstacles in order to help for the navigation of the drone. With these technologies, we can also reconstruct a 3D map of the drone in order to help the pilot for the programming of the mission inside the cells.
And this is another mission for the drone. The drone can also have a reconstruction, 3D reconstruction of the environment. So after that, we can train on this 3D reconstruction environment to have better pilots. And another big point is Perez is another collaboration, another collaborator of the UDD. So we are also here to put startup in UDD together to create some new stuff.